Good evening. Welcome to the QCIS channel. Well, on this channel, you get a daily dose of science, technology, engineering, and math. My name is Leon Jones, and what I'm going to talk about tonight in this presentation is civil engineering materials, or some people might call them construction materials. Now, these materials are very critical when it comes to infrastructure. Now, if you go back to the 1800s, one of the oldest modern structures was built right around 1889, is the Brooklyn Bridge. Now, if you go back even further, you look at some of the Roman structures where they used a lot of arches and buttresses. Those buildings are standing today. And those buildings are built better than buildings today. Now, what did they use? They used a lot of marble, which is stone. Stone is a good material. They've used shale. Now, shale is I call it a powdery material. Brick. And over in Africa, they use adobe bricks. Now, when it comes to these materials, they're all building and they're all construction materials. Now, what makes them unique is they're used in different ways. You have your CMU, which is cinder block. You have your fascia board. You have your joists. But those are some of the types of materials. But let's go deeply into this topic. What are your floor joists made of? Made of wood or timber. Now, some of them are also made of metal. What is your asphalt made of? Stone, tar. What about cement, water, sand, limestone, cement? What about your mortar? I believe it's 2 to 1. Mortar, water. How is soil formed? Well, very, very simple. Soil is actually formed from erosion. Very true, because when you go deeply into your soil, get your bedrock. And when you come up to the top, past your mantle, we have your core, your mantle, your crust. I'm getting into a little bit of geology here. And then you get into your surface. Well, what happens to that stone? Well, over the years, that stone goes through an erosion process. Now, we get in a stone, we get an igneous rock, metamorphosed rocks, but your soil is really made by erosion. It's stone. When you go to a quarry, what are they doing? They're taking big rocks, making them into small rocks. Now you have, I'll give an example. Here in Indiana, we have your base stone, which is 53. In Pennsylvania, we call it GAB. We have number 2 stone, number 8 stone. We even have number 4 stone. Your bigger rocks are used for your riprap. Now, what does all this mean? Well, I am basically talking about materials that you're going to see in construction. And I'm going to share my screen and get right to it, because when it comes to construction materials or civil engineering materials, there are 2 properties that you must understand. They're your physical properties and your mechanical properties. So I'm going to lay it right now. So if you want to learn about what's going on, what I'm here to do is familiarize each and every one of you about the characteristics of construction materials used in civil engineering. So you're going to have the knowledge of properties of civil engineering material, and you're going to develop the skills for identifying suitable construction materials for civil engineering projects. And you're going to have the ability to select the proper civil engineering material. Now, when you select it, it's going to come based on the strength. And that strength is going to come by testing. And this is where you should be a good inspector. As I move on, the contents. Again, we're going to talk about the materials and properties, introduction of materials, construction materials, physical properties, mechanical properties, chemical properties, electrical and thermal property materials. Now, again, when we talk about the materials, you're going to find some of that information in material science classes where you deal with crystallines, you deal with polymers, you deal with plastics, you deal with bonding, everything. But some of that is what you see in civil engineering materials. See, a lot of us know what the material is, but we don't understand the physical and the mechanical characteristics. Also, I'm going to talk about cement and lime, introduction and manufacturing of ordinary Portland cement. The constituents of cement. That's the constituents of cement. Types of cement, cement hydration, properties and field test of cement, special cements, introduction and manufacturing of lime, setting and hardening of lime, applications of lime, comparison of lime and cement. And then we get into fine and coarse aggregates. We're going to have the definition and introduction of aggregates, the mechanical properties of aggregates. What do I mean by aggregates? Aggregate is a stone. The physical properties of aggregates, the importance and methods of grading of aggregates. All right. Cementitious materials. Talk about the introduction to mortars, methods of preparation of mortars, properties and applications of mortars. And we're going to talk about concrete components and manufacturing of concrete, properties of concrete, types of concrete, effects of various chemicals in concrete. And we deal with ceramics and bricks. Talk about the evolution and history of ceramics, manufacturing of ceramics, the properties and applications of ceramics in buildings, the history and evolution of bricks. There are also properties and applications of bricks. You have dimensions of bricks. You have classifications and manufacturing of bricks. And we talk about plastics, polymer technology, types and properties, uses of plastics as a construction material, structure of plastics, and then glass. Glass also has constituents. There's also methods to manufacturing glasses, types and uses, and what is the significance of glass in civil engineering, and what is the advantage of glass, and what is the drawback of glass used in civil engineering. Wood, structure of a tree, general characteristics, types, seasoning of wood, preservation of wood, lamination of wood, paints, objectives, composition, types, consideration, choosing a particular paint, introduction, objectives, and applications of varnish. You get into your metals, introduction about metals, ferrous metals, aluminum, copper, zinc, lead, nickel. These are all basically non-ferrous metals. Again, I mentioned ferrous. Usually your ferrous metals, like your iron, I believe iron can be very, very brittle. Now your steel is basically brittle and ductile. Then you have your aluminum. Aluminum is very ductile. But when we deal with ferrous materials, there's cast iron, steel, types of steel, heat treatment of steel, hot and cold rolled steels, stainless steel, important failures in steels. Again, we deal with ferrous materials. They're your irons, your cast iron, your steel. Within steel, there are processes to manufacturing steel. You have heat treatment, types of steel, hot and cold rolled steel, stainless steel, important failures in steels. This is when you apply, again, you can take a specimen that is cast iron or steel can be used for cast iron pipes. All right, then we get into thermometry or a thermometry of thermometry. Now, what do I mean by thermal? I'm talking about heat. What do I mean by acoustics? I mean sound. So when we deal with uh, th- uh, like a thermometer, I call it thermometry. Well, we're talking about the mode of heat transfer in buildings, thermal conductivity, the fusing of building materials. Every house has insulation. There are types of insulation, such as acoustic insulation, and you have properties of soundproof materials. Now, where am I going to use a soundproof material? If I have a studio, because what does a soundproof material do? It reduces noise. And we have the coefficients of building materials. And then we have some miscellaneous construction materials. And some of these are used for insulation, or they were used for insulation. You don't see a lot of them now. Asbestos. You have to be certified to work with asbestos because over the years, asbestos can become fatal if you inhale too much of it. Then you have plaster, abrasives, rubber, cork, bitumen asphalt, or we call it bituminous asphalt, which is basically asphalt. Then we have road metal. All right, naming all those materials that you normally see, because I work in quality control, what we want with materials, we want basically we have a purpose to have good quality buildings. And a good quality building, we provide shelter. Shelter is pleasant, healthy, comfortable. And when we deal with a well designed building, we want it environmentally friendly. So we have what we call resource conservation. And under the resources, we have MWE, material, water, and energy conservation. Then we deal with life cycle costing. So we're basically right now talking about sustainability, low cost. So we're going to have pre-building. It's going to come from design and material selection, during construction, after construction, and then we deal with maintenance and repairs. We want the building to be human friendly. We want low noise. We want bearable thermal conditions. And of course, if you're an architect or even if you're an engineer, you want a building that is aesthetically pleasing. Now, why is that? Well, you look at some infrastructure around the world, like the Eiffel Tower. the New World Trade Center, the Freedom Tower, the Sears Tower in Chicago, the Big Ben over in England. And one item that people we talk about, it's known as an obelisk. Now, do you know what an obelisk is? Well, if you think about it, it's got a pyramid at the top, and basically it's a rectangular cube at the bottom. And an example of an obelisk is a Washington monument and a clock, one of the oldest clocks here in America. People don't know about it. It's the Bromo Seltzer clock in Baltimore. This is what aesthetically pleasing infrastructure does. It's good on the eyes. If you go in Reading, Pennsylvania, you look at the types of row houses, they're all Victorian. All right. Now, of course, the years are old, but it's not about the years. It's about the material. Of course, this talks about the construction market back in 11 and 12. And this is when construction, after we had the bust of 2008, well, at that time, construction, it really stalled. We had a recession. Right now, construction is going good. And America's, I know here in Indiana, they're building apartments like clockworks. And as long as the economy is good, the construction industry will continue to grow. Again, this data is pretty old. Um, what this slide talks about is it's basically a forecast for the global construction industry. And again, you have to understand when it comes to construction, construction is very stagnated. You're going to have years where it's really good or years where it's bad. Now, also in the construction industry, it also depends on where you go. I'll give you an example. One aspect of construction that has 8 months is generally your transportation construction, unless you're in Florida. After November, temperatures in the west, Midwest, and the Northeast, it's kind of chilly. So you can't do any work on roads. So those inspectors are basically out of work. Now, again, here's a graph of who participated in the global forecast. You can see Western Europe. Western Europe includes Spain, Italy, France, uh, Scotland, England. Again, these charts are very old. And again, this is going over so many information that I presented 2 weeks ago when it came to construction industry. Because now you have your environmental sector, but basically you have engineered construction and you have green building construction. And when we talk about residential construction, again, you're basically producing buildings for human habitation. That's apartments, flats, multifamily townhouses, high rise buildings, and single family dwellings. Then you have your commercial. That's your office buildings, warehouses, small manufacturing facilities, markets, and shops. And basically, your commercial also features retail and wholesale stores. Then when we get into your institution, that's where your hospitals, your schools, your medical clinics, your universities, your government buildings, your churches, and your athletic stadiums. And you deal with industrial construction. It's a special segment of the industry that develops large scale projects. That's basically your factories, your manufacturing plants. Now, such endeavors result and facilities that manufacture and process products, your steel mills, your electric power generating plants, petroleum refineries, petrochemical processing plants. Now, talk about engineered construction. This category of construction, sometimes called engineering construction, you basically see designs prepared more or less by engineers rather than architects. Now, the provision of facilities is usually related to the public infrastructure and thus owned by public sector entities, and they're provided through bonds, rates, taxes, and a high degree of mechanization and the use of much heavy equipment and plant in the construction process. Now, examples: PSDP mega projects in Pakistan. Okay, again, when we deal with engineered construction, basically we're talking about heavy construction, highway construction, building material. Again, getting back into building material. It's used for construction of buildings and roads. Classification is based on source of material. Again, as I mentioned, you have naturally occurring, and under naturally occurring, you have your aggregates, your sand, your timber, your stones. And then you have your manufacture, your cement, your tiles, your pipes, your steel bars. And then you have your classification based on use of material, traditional, naturally occurring substances. So you have organic material and inorganic material. Now, your organic material is woods and bamboos. I did a video on how bamboo can be used as a sustainable building construction material. But when we deal with something inorganic, talk about gravels, lime, stone, and clay. Those are under traditional. Again, those materials are traditional. And we deal with modern, that's synthetic material, plastics, petroleum-based paints, blocks and bricks, concrete, metals, and foams. Again, construction industry of the world is one of the largest industries. Construction is a huge industry. In fact, you have three areas where you can become employed even without a degree. They're manufacturing, construction, and hospitality. A lot of work in those fields, especially if you don't have construction. However, if you are patient, you learn the ropes, you can get promoted really quickly. And it's much easier to get a job, even if you're going to college, if you're relocating. Now, there's a conceptual model for sustainable design or green design. So here with this chart, sustainable design and pollution prevention. Sustainable design and pollution prevention. Here are your principles. So you have your economy of resources. Remember I told you about EWM? Well, you see it again. Energy conservation, water conservation, material conservation. Then we get into low cost or life cycle designs. We have a strategy. So we have a pre-building phase, a building phase, and a post-building phase. Then we get into humane design, preservation of natural conditions, urban design, site planning, and we design for human comfort. And there are methods. General properties of construction or civil materials. General properties you're going to find again. There are three. Now, I told you there were two, but there are actually three. Most of the time we deal with, if you're in mechanical engineering or civil engineering, you basically deal with the physical and mechanical because you're testing them. Because you're basically dealing with some solids, some brittle, some ductile, some plastics, but there's also chemical. Now, there are others, like if you are in the fiber optics, Optical, if you're into sound, acoustical, heat, thermal. Then there's electrical. Now, again, as I stated before, most construction engineering or civil engineering applications focus merely on physical and mechanical properties. Now, when I talk about physical properties, what I'm dealing with a melting point, a freezing point, a density, a porosity, a specific gravity, permeability, thermal conductivity, electrical resistivity. Then I'm also dealing with surface energy, texture. Now, the texture could be micro or macro, and then other could be thermal. You're dealing with the shape, the color, and of course, the expansion. Now, mechanical materials. Now, we're getting into some mechanics of materials, and you're going to see a lot of this information, particularly on the civil and even the mechanical side, when you take courses like mechanics of materials and materials testing. You'll see all of this information. But if you've taken those courses, like I've had, you're going to see one word or two words. You're going to see stress and strain, and you're going to see loads. Now, when we deal with stress, all I'm dealing with is the resistance to applied load. So what I'm doing is I'm applying a load. Let's say this is plastic. I'm gonna apply a load, and I'm gonna keep on applying a load until this fails. That's the stress. Now this is gonna happen initially, or it could be over time. We're gonna deal with stiffness. That's the property to resist deformations. The strength, the ability to withstand various forces. This is metals, the ability of metals to withstand forces, various forces. Then we have your elasticity, the ability to regain its original shape and size after the removal of the loads. And we have coefficient of softening. That's the ratio of compressive strength of the material that has been saturated to the dry state. Then we have resilience. That's the work done to deform a material up to its elastic limit. Hardness. That's the ability to resist abrasion, scratching, and indentation by hard material. Ductility. The ability to elongate permanently under tensile forces. Remember I told you about a pull test? You take a bar, a specimen. It could be aluminum, cast iron, or it could be steel. And what you're doing an elongation test basically with a machine. It could be a 602 controller machine. And what you're going to do, you're going to put that steel bar in that machine, and that machine is going to pull it apart at a certain load. That's where you're going to find the elongation because you're already starting off when the bar hasn't failed. You're going to have a diameter, and then you're going to see how much the diameter stretches after the specimen has failed. And then your malleability, that's the ability to permanently extend in all directions when hammered. Brittleness, that's the tendency to break suddenly when elongated. That means when I stretch it. Then you're going to have creep. It's the slow deformation under long-term sustained loads. You have flexibility or pliability, tendency to change shape under different stresses. Fatigue, that's a repeated application or cyclical load application and resultant stresses. Then there's toughness, the ability to get twisted, bent, or stretched under high stress before rupture. Now, that's when you do what we call the torsion test. You take a, suppose I had a metal like this. There's also a machine that you load up, goes around and around and around and around. And what it does, you can take a specimen and twist it until it breaks. And what are you applying on it? That's known as a torsion test. So you're going to apply some type of torque onto that material. And when it breaks, you're going to see the shape. Thermal properties. Well, you have your thermal conductivity, the ability to transfer heat. Under the ability to transfer heat, we have porosity, characters of pore, moisture content, weight of the material, mean temperature. Very important for material used in walls, panels, and glass claddings. And we have your thermal capacity or heat capacity. That's the ability to hold heat. Under that section, as we get into the subsection, it's closely related to the weight of material. We're talking about thermal or heat capacity and the ability to hold heat. It's also used for calculating thermal stability. Again, that's the ability to hold heat. Then we get into our physiochemical properties of building material. So you have your hygroscopicity, or or hydroscopicity. It's basically shrinkage or swelling, or we call it a change in volume of the material due to moisture change. Then there's water absorption, the ability to absorb and retain water. Now, one construction material that does have chemical in it is concrete. You have different types of concrete. Okay, then you have your metallurgical properties of building material, which you have fusibility, able to become fluid when heated. Usually takes place at melting points or melting point in metals. Weldability, the ability to adhere firmly to the part of the same. In other words, talk about welding. We're welding a piece of metal to a second piece of metal. And when that weld dries, it's supposed to be strong enough to fuse the metals together. I mean, you have different welds. You have an arc weld, you have a fillet weld. You actually have plans when you deal with welding. Then you have your hardening, the ability to become hard when heated. Tempering, lowering the degree of hardness by heating and cooling repeatedly. Your electrical properties of CE material. Resistivity, the ability to impede flow of electricity. Conductivity, the ability to allow current easily. Dielectric strength, the insulating capacity against high voltage. Then you have your superconductivity. Then, and I'll explain a little of this after I complete this presentation, determining the properties of CE materials. Properties are determined by testing. There are two types of testing. It's laboratory testing and field testing. This is what you go through when you deal with QA. So, something that you must understand when it comes to testing, there are different standards. ASTM is the American standard. So, to avoid any inconsistencies in test results, standards are devised which describe the test apparatus and the procedure. Now, items that are usually standardized in a test are, why did you test? Well, you want to make sure that your specimen meets the standard specifications. What you have to do when you test, first you got to obtain test specimens, and you have to have a number of specimens. Then you look at the size and shape of the specimen. Then you have preparations of specimens for testing. I'll give you an example. When I am preparing to test concrete, Well, what am I doing? Well, I have my thermometer out because I'm going to take the temperature. I have my air meter out and I'm going to weigh my air meter because we're going to do what we call a water cement ratio in the field. So I'm going to measure my bowl to my air meter. I have my cylinder molds ready because I am actually going to use concrete to make the cylinder molds for compression testing. Also want to have my slump cone and my tape measure. That's what I'm talking about, preparations. Now, when I talk about obtaining test specimens, well, again, let's go to concrete again. Basically on a third truck and in the middle of the chute, that's when I'm going to take a wheelbarrow, take my thermometer, I'm going to take my scoop, and all this equipment has to be calibrated so you get accurate readings. And I'm going to collect my sample from the truck, going to be in a wheelbarrow. And that's when I'll make all my cylinders. That's when I'll run my air test, my temperature, slump test, and then type of machinery, rate of loading, interpretation of test results. And then I'm going to write a report. This right here, this 8-step process is QA testing. It's in the field and in a lab. This right here. Now, there are different ways you can present it depending on what material. But in order to test any material, you have to obtain the sample. Then you have to look at the size and shape of the specimen. Then, how are you going to prepare the specimen for testing? Then, take a temperature and a moisture during preparation and testing. Depends on what type of material you have. What type of machinery you're going to use. Rate of loading. Interpretation of test results once you've taken a test. Then you write your report. It's basically all you do for field and laboratory testing. Now, remember I told you about standardization. Well, here are some of the countries that have standardization for quality standards. So you have Pakistan Quality Standards and Quality Control Organization, PQS, QCA. You have the Turkish Standards Institute, TSC. England has the British Standards Institute, that's the BSI. Germany has the Deutsche Institut Norm, the DIN. And I just mentioned it for America. We have ASTM, American Society for Testing and Inspection. Now, if you're going to do roads in America, we also have ASHTO, which is the American Association for State Highway Transportation Officials. We have American Concrete Institute, and then we have NICET for people who are in the business of technicians, being technicians. That's the National Institute for the Certification of Engineering Technicians. And then you have local type of testing, like the Washington Area Council for Engineering Laboratories, known as WASL. You take a test in soil and concrete. And then for Europe, you have SIN, that's the European Committee for Standardization. And of course, there are many more, but I just wanted to give you an overview of the materials, what's involved with the materials. Why do we use certain materials? But basically, overall, materials are chosen based on the design, and in that design, it could be strength, it could be the testing, it could be the functionability, it could also be the life cycle. But for the most part, we deal with civil materials, most of the time we're going to deal with mechanical and we're going to deal with physical. Yeah, there's sometimes we get into chemical, electrical, thermal, but basically we're using mechanical and physical. Why? Because basically the materials that we use, no current traveling through those materials. So we can't use electric. We're not using a lot of heat unless we're utilizing steel. But it's very important that you understand these materials on how they're made because you have natural materials and you have materials that are basically prefab materials. But overall, just wanted to give you an insight of civil engineering materials, and I'll probably have a part two to this so I can show you what types of materials, what types of tests are involved. Because if you're getting into the construction industry and you don't want to be a surveyor or you don't want to be a CAD tech, the best place to go is in construction. Start off as a technician. Learn how to test the materials. Learn how to take reports. Learn how to interpret data. Very important. And once you go from a technician, you move to an inspector. Now, you can do all this without even having a degree. Yeah, you have to take certain tests, but there's some people who don't want to be engineers, but you can still make a decent living without having a college degree. You can gain the skill. I gained my skills before I even got degrees. That's why I know the materials. That's why I can teach. The bottom line is this. Understand that civil engineering materials, when we test them or when we talk about them in a classroom session, deal with the mechanical and physical properties for the most part. And that concludes this topic on civil engineering materials. If you like what I just presented, please comment, share, and subscribe. And if you're looking for some political content, you check out my main channel, the 411 Talk Zone radio show channel. Now, here's what I do when I record all of my videos, because I have two channels on YouTube. Now, 411 Talk Zone radio show, when I finish recording a video, I upload that video to X. Then I also upload the video to Rumble. Now, Rumble's a little slow when you upload videos. They have to work out the kinks. They're getting better. Their interface looks a lot like YouTube, but a slower version of YouTube. And then once I upload the 401 Talk Zone radio show channel content to Rumble, I then upload it to Truth Social. Now, for the QCIS channel, I finish recording a video. I also upload that video to X. And since it's a more educational video where a number of engineers hang out, that video is also uploaded to my LinkedIn page. And once again, thank you for viewing this content on civil engineering or construction engineering materials from the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. Until next time, my name is Leon Jones. You all have a wonderful and gracious evening.